I guess it's time to begin. It's 3 minutes past 5. So in case you haven't noticed, there's some drinks in the back, some snacks. There's some swag here. Grab a shirt or whatever you can find when you go. And that's all from us, from Arado. And I think that is enough from us. Tonight we have, this wonderful afternoon, we have 3 speakers. 2 from Royce. One of them is actually my old colleague from IT. Great guy Aleksis, who's going to be starting. And the theme for the afternoon is autonomous ships and ferries, in short. And I'm pretty sure you guys didn't come here to listen to me speak, so without any further ado, please give it up for Aleksis.
Okay, thanks. Yes, thanks. Now, before I go into my presentation, just want to say thanks to Arado for arranging these events. That there's been so many of them already, and I see the amount of people just growing each event. So thanks a lot, Arado, for arranging these events for now. Okay, so my name is Aleksis Tulonen. I'm from Rolls-Royce, and my role there is software test lead. And today I'm talking about, on a higher level, on the development of autonomous ships, which is, it's rooted in our mission, which is redefining shipping with autonomous solutions. But before we can actually go into discussing about autonomous ships, I think we need to first discuss a bit about what do we mean by autonomous. Because if we think about let's say the trip from no autonomy to full autonomy, it's not a one step. There's a lot of different phases, levels, degrees, and little by little we are automating the tasks that the ship is able to perform. And one way to, how do you assess if, or how autonomous the system is, how do you assess that? Well, basically you ask how independent the system is in accomplishing its tasks without the human interaction. And this is an important thing to ask when you start to design an autonomous ship, because you need to basically decide which are all the different tasks you want to automate. Because there are some really challenging ones. Let's say if we talk about cruise ships, large container vessels, how do you do the docking, which is very manual labor. There's not any easy solutions for that. So maybe when we talk about autonomous ships, which come to our seas in the following years, maybe they are not fully automated from start to end, but there are some tasks which still the human is doing. So it's good to understand that when we talk about autonomous ships, there must still be many tasks that the human is doing. In case of cars, some people have probably seen these different levels, which are very often referred to. So we have a starting point of no automation. I don't know, maybe these days you would need to go very many decades back with cars having no automation. But with cars, we have seen many examples of little by little we are automating the tasks. And one crucial let's say a shift is, you see on the left, the blue ones and then the green ones. So the human driver monitors the road, and then we go to the automated driving system monitors the road. And these days we are starting to shift to the automated system monitoring the road. So we see, for example, examples from, let's say, Volvo. They are monitoring the road and making braking when they see something that well, requires braking. So it's this gradual change toward that we are more and more giving the control toward the automated system. But even still, if we refer these days to autonomous car, still there's a lot of, let's say, situations where the human can intervene and take the control. Then this is a proposal from Rolls-Royce. We proposed this, there was this International Maritime Organization's Maritime Safety Committee, which was a long meeting last week. It ended last week, and we proposed this framework there. International Maritime Organization, it's an important organization because if we think about navigation rules, it's an organization that will heavily influence that, and the current rules don't consider autonomous ships. So they are discussing about these same levels that the car side has already long time discussed, and they are trying to get a common understanding on what do we mean with different levels of automation, and that will affect on the regulations and the laws, because you can bet, well, this is my personal opinion, but I think we will not allow first totally full autonomy. There will be some kind of, let's say, not full autonomy, but something less. And these are the same things that are being discussed at the moment. Like, what is the role of the human in the ship? And in which kind of situations the human will take the control. Now, if we think about a little bit also on the why are we going into the autonomous ships? Why do we even make that effort? Well, as in business usual, it's pretty much costs come very often into the picture. If we think about, this is an internal study based on Rolls-Royce internal study, and we concluded that about 38% of the annual costs go to fuel and 17% to manning. So that makes roughly over 50% to fuel and manning, and these two are heavily influenced by autonomous ships. And this size ship that we're talking about here, it can consume fuel per day about, let's say, 30 to 50 tons, depending on the ship. So you can see that even 5 to 10% decrease in the fuel, that's a big impact on the cost. So if you can find a way with more effective, fuel-effective navigating to lower the cost of, or lower the fuel consumption, then that's a big driver for whoever wants this kind of technology. And manning is, of course, if you don't have a crew, well, you will get the manning savings. But there are other reasons. If you don't have the crew on the ship, then you can redesign the ship in a totally new way. You can get rid of the hotel systems and the deck house, which leads also to the lower power demand. You can put more cargo because you don't have those facilities which would be dedicated for the crew. Of course, you would need more sensors, which do not exist that much yet. So you would need sensors like LiDAR and radar. Well, radar does, but all different kinds of cameras and such like that. I will discuss a bit about that later. And also needing, let's say, to improve the reliability of the machinery. Because if you don't have people on the board, well, who's going to fix if there's some kind of failure on the machinery? Then other reasons for aiming at autonomous ships. Maersk is one of the biggest container shipping lines in the world. And they are a bit worried with companies like Amazon and Alibaba. Amazon and Alibaba are companies that are heavily automating their logistics chain or the supply chain. They want to make it as effective as possible and as quick as possible when somebody makes an order and when they receive the order. And they are missing the visibility for their deliveries, especially when they are on the ocean on the container vessels. So if you're able to automate as much as possible of the supply chain, that can lower the variability and you get more predictability and you can optimize the whole flow. So that's also one of the reasons why companies like Amazon and Alibaba want to improve the whole supply chain. But that's not all. Those are like kind of like rational reasons and business reasons. About 8 months ago, when I joined Rolls-Royce, actually just a little before that, when I applied to Rolls-Royce, I was just thinking about, like, let's say 30 years from now, if I look back to my career, will I feel that I had done something that really meant something? That it had some kind of, let's say it pushed our humankind forward. It actually, I was part of doing some kind of solutions that changed something. And I felt that there could be an improvement on that side. So I wanted to see if I could be part of doing something that actually could change the world. And the main reason why I concluded that this would be such, because there are so many people who think that the autonomous ships won't be a reality. But I would say that compared to last year, those voices are becoming more silent and silent. Because there's more and more companies who are doing this, and more demonstrations and actual implementations that show that it's possible. So I think it's not all need to be rational reasons. I think we also need to consider that things that we are doing, are they actually pushing us as a humankind forward? Are we making something that next generations can build up to? Not to say that the products I was involved before, like e-commerce sites and those, they didn't have value, but 100 years from now, who's going to remember that? Okay, just a few words about what we do in Turku, not only in Turku, but we have about 70 people in the Turku office. It's like a couple hundred meters from here in the Trivium Center. There's a lot of different skills. And by we, I mean the ship intelligence unit of Rolls-Royce. We also have maybe 20 people in Norway and a few in UK. So there's all kinds of different skills: hardware engineers, architects, software developers, former captains. There's like 500 years of marine experience, 120 years of just navigating experience from the ships. Then there's project managers, UX designers, system test engineers. So we have a lot of different skills that we believe are needed for building these products. And how we've divided the work is in such a way that we're focusing heavily on this remote and autonomous operations in Turku. And the main, let's say, blocks of autonomous ships are the intelligent awareness product. It's basically, I'll mention a bit more in the next slides, but we have sensors that provide information and that gives us opportunity to detect all kinds of objects that we want to detect. Jussi will tell after my presentation more on how it happens in a practical level. Then we have a remote operations center. This could be, for example, let's say we have autonomous ships. You want to monitor that, how all the ships are moving in different places, and maybe you want to take one ship in remote control. So this is something we're also implementing. Then there's the autonomous navigation system, which is basically the brains that we need for steering the ship. Then the intelligent asset management side, that's something that is done mainly on the Norway. And it's basically we're just getting as much as data as we can from the ships. And then there's AI and for example, recognizing if there's some kind of failure coming up for the engine, and you should do something before it actually breaks. But it's heavily involved into just utilizing the data that we can get. Now, if we talk about building blocks of autonomous ships, so this year we're heavily focusing on the intelligent awareness product, and then there's the autonomous navigation system, which comes next. So first you get the understanding about the surroundings of the ship, and then you have a logic that will, the system which will make the decisions based on that understanding. And then comes the possibility to remote control or just monitor your fleet. Now, a few words about the intelligent awareness system. So basically, we have sensors like visual cameras, thermal cameras, radar, LiDAR, all kinds of different sensors that we believe is enough for getting needed information about the surroundings, and in many times better information compared to that you would be just human sitting there and watching from the bridge. Because many times these days it's radar is the basic or the best possible sensor there that you can gain knowledge about what's happening around you, especially if it's nighttime. So this is the first step that we need for the autonomous ships. After that comes the autonomous navigation system. Now, if we think about what challenges there is with developing these technologies, of course we have all the same challenges that everybody has. We have people located in different places, so it's how do you manage the work with all those different places effectively, and how do you align you have same goals, objectives, and that's business as usual. But if I compare to previous places I've been, one of the big differences I've noticed is the complexity. Many of the solutions and problems we're trying to solve, they are just complex. And this is one way to evaluate complexity. It's by Liz Geoch, who is, if you know BDD, Behavior-Driven Design, she's one of the authors of, or the co-founders of that. So many of the things that we do, I've noticed that they go to 3, 4, or even 5 in the complexity. And that basically means that it's really hard to plan in advance. How do you gonna implement something that you were meant to implement? So what do we do then? This is basically what we can do. When there's a lot of complexity involved and you don't know how you're gonna implement, let's say you want a video stream from the ship to the remote operating center, but you don't know what would be a convenient way to do that, and is it even going to work, what kind of problems you will face. So you do probes and trials. Maybe you try out with a couple different options. You spend a week, 2 with that, and then you have the understanding how you're actually going to do that. And I've noticed that many times let's say we have stories, and you try to implement one, and you don't know how to do it. So we need to do spikes, which is one way to call them, but it's basically probes and trials. You need to do the thing in order to know how to do it. So that's what I've noticed, and I don't think we should fool ourselves. If there's a lot of complexity involved, you can't just plan it in advance. You need to do a lot of experiments. Those give you the information needed for actually proceeding. And that's what we need a lot in order to proceed in our context. If I want to raise some themes related to the challenges, of course, the technology and the just complexity. If we want to have sensors for the intelligent awareness and gaining the understanding about the surroundings, there might not be the best sensor, let's say the sensor that would be just the right fit. So you need to just use the one that you can find, and maybe that's going to be enough then. Then there's the security. You can bet that autonomous ships and even remote control ships, those are something that there's many people out there that would like to be the first one to hack those. So security is something we're lucky to have really skilled people working with us as colleagues who make sure and help us to implement and put the security into the design and the architecture from the day one. Then there's the regulation and the legal side. It doesn't really matter, even if we would be able to just make the perfect autonomous ship, and there would be no failures, no bugs, anything, and there would be a lot of customer paying for it. But if the laws and the regulations don't take into consideration autonomous ships, those ships won't travel anywhere. So we have also people working with organizations like International Maritime Organization and the governments to get the laws being changed and also the navigation rules. Because we will fail in the end if those don't get changed. And it's always easier, of course, to start with the local waters. Finnish government is really, let's say, they are collaborating with us, and they are making their best to enable autonomous ships at least in Finnish waters. But there's a lot of countries in the world, and if you want one autonomous ship to travel from here to, let's say, Panama, well, there's a lot of work to do with the legislation. Then there's the safety, and this is something that I haven't paid that much attention in the past, because many of the things we've developed in, let's say, e-commerce sites, web portals, internal applications and such. But if we talk about autonomous ships, safety is just something that you need to take really seriously. It doesn't really matter if you have a piloting or some kind of demonstration. You need to think what kind of risks there are, also from the day one. When we design it, then how will we mitigate different failure scenarios, and what could go wrong, and what we will do if the system will fail, and who will intervene then. And safety is just something that you need to really consider, because if we mess up, it can mean people dying, and that doesn't usually happen in our work. In the past, we've had bugs in production. It's always a bit embarrassing. It's frustrating, but life goes on. But in this case, somebody can die, so it's a bit different. This is something that, in a context where you're designing these kind of systems, you really need to take this seriously and take it into consideration like you take security and whatever risks there are. Okay, then a couple words about the testing part. If I want to raise some high-level teams, well, naturally, there's a lot of software involved and testing of those. Then there's a lot of hardware. Even though we wouldn't manufacture the hardware by ourselves, and we would buy them elsewhere, it's always the question, because if we think about this system, first we need to think about where it's going to go, and what kind of environmental conditions it will be operated. Then we usually check from the specifications of the hardware we have. Will it survive in those conditions? Will it survive the vibration of the ship, or the moisture in the air, or the heat in the whatever location it's installed? But then it's also the question, do we trust the specifications, or do we need to test this ourselves? It doesn't help much if the system goes down because some device has a failure. It doesn't help if we raise the specifications at that point and tell that it's said that it would operate in these conditions. So there's a lot of test activities also related to the hardware. Then there's AI, which requires a bit different approach than traditional software. I'll just mention a few words about that later. And connectivity and security require just, well, we have people who are really skillful at that, and they focus these more than, let's say, others. So especially in case of the security, that's where we have many people who have just specialized on that, helping the teams. But we also need systems thinking. This is not, of course, specific for our context, but if we think about autonomous ship, it's a system. It's a whole system, and there's a lot of subsystems. And well, one, if you think about teams which have been implementing any subsystem, one way to look at it from the systems thinking perspective or Conway's law is how those teams have been communicating with each other. That usually reflects to integrations between them. But just generally speaking, usually system itself or the subparts of the system, they can work fairly nicely. But when you put all together, that's where the problems usually arise. Then in case of test activities, we utilize testing quadrants. It basically it's a sort of a mindset. I think there's also details, but it's sort of a mindset that there's test activities which focus on our expectations, like what have we defined in the acceptance criteria, specifications, requirements, and so on. But then we also need to test against just like exploratory testing, or maybe we bring the captains to give feedback from the usability perspective. So this gives us also opportunities to catch problems that we didn't think. Then another mindset that we have is that we want to make it really hard for bugs to get through. And we do this by implementing a lot of feedback loops. So you implement something, we want you to be able to get in many different ways feedback. Maybe you do pair programming, or you have a pair review. Then you have those unit tests, integration tests, CI build with tests. Then you have static analysis, which will analyze what you've done. So you have a lot of feedback loops, and that's one of the mindsets that we have, that we need to have a lot of those in order to have diverse ways to catch problems. But we also need to challenge, if you look on the app, we need to also challenge our understanding of the system we're building. So we do things like failure mode defect analysis, hazard analysis, or test idea brainstorming. Just to catch those things. It doesn't. The tests usually don't catch that well the things that you didn't implement. That usually we can catch by doing this analysis and challenging our understanding of how the system should behave. As a final slide, I'd like to just mention about the AI systems. We use AI, for example, for object detection and object tracking and classification. And with AI systems, you need this shift from deterministic to probabilistic approach in testing. And what do I mean by that is that traditionally, let's say you have automated tests where you would conclude if the system is able to find all the needed objects from the picture, and based on that you decide if it's pass or fail. But with AI systems, let's say we make a change. We're not interested of if it will recognize in one picture. We're interested of, let's say there's 10,000 pictures, and what percentage of all the possible objects that we wanted to recognize, what's the percentage that we were able to recognize? Because when we change the system, let's say it can be that there can be differences in one frame, but we're not interested of that. We're interested of that we are able to detect as well as possible when we think a larger sample size. So instead of concluding based on one frame, we're comparing to acceptable level and deciding based on that if the system is working as we're expecting. Okay, and that's it.
Thank you, Aleksis. Any questions? Well, I can start. The classic questions. What do you think? When is this technology going to be sort of open to the public? When is a self-sailing ship or this autonomous ship going to be a reality?
Yeah, that's a hard question because I actually asked from the management just guidance on what I can say and what I can't say. And schedule was one of the, and the deadlines were one of the things that our ship intelligence unit boss said that don't tell anything about that. Right. So I think time will tell, and we will tell immediately when it's reality.
Good answer. All right, any more questions?
Yeah. Related to the schedule, have you done any practical tests in waters yet for any of the system? You don't have the autonomous navigation or anything like that, but
I would say that from the public examples, closely related to that is I would say with what we did with Switzer. It's a public example. It was a remotely controlled ship where we also utilized the object detection. But yeah, that's the example I can give to you.
I'd imagine that the hardest phase in a ship journey is arriving and leaving from a dock. The actual journey is the easy part. Mm-hmm. I was thinking, is there going to be an intermediate phase where a crew is going to drive the ship out of port, then it continues automated, the crew flies back with the helicopter, and in the other end, another crew arrives to the ship and drives into the port?
I can't say that we have discussed that exactly example, but yeah, if you think about let's say how it usually goes in Finnish waters, it's there's this, I don't know what it's called it's luotsi in Finnish. Usually, yeah, pilot comes because that's the tricky part, especially if we are in the waters where it's really challenging. But also, if we think about cars, what usually came as first is the parking assistant. So this is definitely something that could be the first things to. It's also, of course, harder than just going in the ocean directly. But I don't know if it would go with the helicopter. But I think maybe that could be a reasonable guess that that could be something that would be implemented first to do the parking. Let's say with these passenger cruise ships, for example. So this parking could be one. Of course, the one challenge with that is the docking. So, but maybe you would do that not automatically, but manually. But yeah.
But I think that's also a very good case for the remote system because they are remote and autonomous. Yeah. So I think for a long time there will be scenarios where we operate remotely, and we will probably have like remote control centers where captains can take control in some situations and then let the autonomous ship take over when it's now suitable for the environment.
Yeah, if it weren't heard in the video, Jussi commented that instead of flying the crew, it could be that this pilot would take the ship into control remotely. So that would be one way to handle it also.
All right, I think we'll
carry on.
Yeah, so we'll cut off the questions, but he's going to be here all night, so just grab his hand whenever you can. And let's continue.